Hello, everyone. Welcome to the weekly problem of Epic Science Academy. So in this week, we have a very interesting mathematical problem here. So if we know that x equals m over n, and we also know that m is not equal to n, and n is not equal to 0. So can we try to translate this expression in terms of x? This is a real AMC competition problem. So the calculation of the problem may not be that difficult if you understand the concept. The concept that we have here is how do we convert an expression in terms of a list of new variables. Okay, so this is a very important mathematical multiplication technique for your future studies. So if you are going to learn things like calculus or calculus-based physics, you will need to use this technique very frequently. So let's just try to look into this problem and how do we solve it. There are a few ways to solve this problem. Let me just try to show you two of them in this video. The first way is more conventional. So probably you can use this way to solve most of the problems in this category. Okay, so what we do is we just use existing conditions and try to replace these variables we have here in this existing expression with the one that we want to have. For example, in this case, we have m and n in this existing expression, and we want to replace m and n with x. So how do we do that? Well, we just use what we have here, x equals m over n, and we will just multiply both sides with n, and we have n multiply x equals m. So we can actually know that m equals n multiplied by x. So now we can just replace m in this equation with x. So you may ask, what do we do by n? Okay, so let's hold on for a second. So we may find a solution later on. Okay, so how would we do that? Basically, m plus n, m minus n. Okay, so we replace m with n multiplied by x plus n and n multiplied by x minus n. Okay, so now you would probably see that n is a common factor for both the numerator and the denominator. Okay, so how do we do that? Well, we just try to move x to the beginning of the expression for both of the numerator and the denominator. So we have x plus 1 here for the numerator. And then for the denominator, we will have n x minus 1. Since we know that x is not equal to 0, so we will just cancel x here, and we get x plus 1 divided by x minus 1. Perfect. So we have eliminated m from this equation by replacing m with x multiplied by x. And we were also able to get rid of n just by canceling the common factors from both the numerator and the denominator. Now, the expression is only represented by x, which is our goal here. Okay, so there is a second way for this problem. Okay, so the second way will require a little bit of mathematical sense. So you need to have some kind of observation about this expression. So we have m plus n and m minus n. Okay, so we know that x equals m over n. So in order to put x into this equation, so basically we want to have some kind of m over n in this equation. Okay, so how do we get m over n in this case? Well, we'll just try to divide both the numerator and the denominator by n. So we know that we will have m over n. Okay, so let's just try to do that. So m plus n and m minus n, and both of them will be divided by n because we know that n is not equal to 0, right? So we will just distribute n into these two terms here, and we will have m over n plus 1, and we will have m over n minus 1. And now probably you recognize that here this is x and this is also x, and we will have x plus 1 and x minus 1, which is exactly the same as I got from the first method. Okay, so this second method will require you to be able to recognize, okay, so in order to get x, which is m over n, so how do I do that? Well, I just need to divide these expression by n for both the numerator and the denominator. Okay, so these are the two methods that I have to share with you for this week's problem. As you can see, the mathematical calculation for these two methods are not difficult at all, right? So if you understand this concept, okay. So as I said, this is actually a very useful method. So if you look at this end result here, this is actually something that we can represent as a function of x, right? So the original function we had was a function of m and n. So in this particular problem, we were able to convert a function of two variables into a function of one variable. Okay, so this is a very, very useful technique that you will need to use in your future studies. All right, so that's all what I want to share with you for this week. And I hope you enjoyed watching the video. Thank you.